I try to imagine a fellow smarter than myself, and then I try to think, what would he do?
Charge up your axons, ready your receptors, and shift your lobes into upper beta phase. You are listening to Smart Drug Smarts, the podcast dedicated to helping you optimize your brain with the latest breakthroughs in neuroscience, nootropics, and psychopharmacology.
Hello and welcome to Smart Drug Smarts. I am your host, Jesse Lawler, excited as always to bring you another episode of Smart Drug Smarts. This is episode number 14. We're going to be talking this week with a multi-time author about all things brain. This is Judith Horstman. She is a writer for Scientific American, and she's probably one of the more well-read people in the world about sort of broad spectrum what's going on in neuroscience. She's written 4 books in the last 4 years for Scientific American that are each sort of synopsizing the state of the state of the research industry, whatever you would call it. Sort of the latest. Here's what's going on in this area of brain research nowadays. We're going to be talking with her specifically about her book Scientific American's Brave New Brain, which is kind of exploring the frontiers of things like smart drugs, things like brain integration with computers, surgery types which have not been contemplated in the past. All sorts of really interesting stuff. So we'll get into that with her in a little bit. If you hang around until the end of this episode, you're going to hear something which has never ever been heard before on Smart Drug Smarts, but is going to be a part of this and all future episodes, and is probably one of the more responsible things I've done in the history of this podcast. But before we get to that, let's do This Week in Neuroscience.
Smart Drug Smarts, This Week in Neuroscience.
So scientists were studying macaque monkeys and came across something kind of by accident that they've been looking around for a long time, which is there's sort of been an open question of how the brain timestamps different events and keeps track of what things happened in what order. This could be both short-term memory sort of things like did I put my keys down on the table before or after the rhinoceros ran through the room, to things like what came first, my second grade graduation or my high school prom. And it seems almost intuitive, like, oh well, of course this memory happened before that memory, but how actually is that mapped within the brain? Well, it seems like the answer, although it's still sort of a theoretical question, the answer has something to do with these neurons that they've discovered. This study found them in both the prefrontal cortex and the striatum, but they suspect they might very well be in other parts of the brain as well. These neurons, which essentially work like cellular metronomes, firing at sort of fixed intervals, entirely devoted to this tracking of the passage of time. Peter Strick, professor of neurobiology from the University of Pittsburgh, commented that we have sensory receptors for light, sound, touch, hot and colds, and smell, but we do not have sensory receptors for time. That time is a sense constructed by the brain. And so these neurons seem to be part of how that sense of time is constructed by the brain. They think that this might also lead to some new treatments for Parkinson's, because it's theorized that part of the problem that Parkinson's sufferers are dealing with is just due to the brain's inability to correctly keep track of time. The brain is all about controlling our body's physical movement. That's ultimately its most important task. And if you're not sure how much movement has taken place since the last time measurement that your brain took, then that's sort of what leads to these shaky movements that are not as coordinated as we would want them to be. So they think that by helping these neurons that are keeping track of the passage of time keep track of the passage of time better, it might help smooth out some of the rough movements that people who are suffering from Parkinson's have to deal with.
Smart Drug Smarts.
So I've actually gotten a lot of listener mail over the course of the past week or so from the podcast, which is really great, except one of them, which the timing was just so rotten on. It was the day that I published the episode 13 with Sebastian Marshall, and I got an email from Robert who has said, "When's the next podcast, man? It's been 2 weeks, and I'm craving some Smart Drug Smarts." So anyway, he took me up on my standing offer to allow people to pester me if I get too far behind on publication. So anyway, thank you, Robert, for calling attention to my absolute lateness on getting episode out. But anyway, hopefully won't be quite as ludicrously late this week. Also got a 5-star review on iTunes this week from Art Means Nothing. That is the name of the iTunes reviewer, who said, "I love this podcast and find myself listening to particular episodes repeatedly. A+. That's totally awesome. I'm curious which the episodes are that get the repeated listening. But either way, very happy to hear that. If anybody wants to leave a positive review on iTunes, I will be absolutely thrilled to accept it, and probably butter you up in a future episode. But let's jump straight into the interview now. This is Judith Horstman. This was a long interview. We talked for a long time. Most of the people that I talk with on this podcast wind up having maybe 30, maybe 50 minutes at the outside conversation, and then editing that down to the length that you hear, which is typically maybe 60% of that. We cut out all the parts where people are sneezing and hiccuping and the phone's ringing and dumb stuff like that's happening. But Judith and I, we got on like a couple of old sailing buddies or something. We talked for probably a good hour and a half. So we will see how our faithful and hardworking editor, Ben Kruger, decides to cut this up. I don't want to give you an hour-long episode, but it might be kind of a longer one. So anyway, I should stop talking now. Let's jump straight into it. So I'm talking now with Judith Horstman, and she is the author of numerous books, of which a few are The Scientific American's Guides to Healthy Brain Aging, the book of Love, Sex, and the Brain, A Day in the Life of Your Brain, and the one that we're going to be talking about, because I've actually read it myself, is The Scientific American Brave New Brain, How Neuroscience, Brain-Machine Interfaces, Neuroimaging, Psychopharmacology, and all sorts of other stuff are going to be affecting all of our brains in the relatively near future. And some other stuff too. You want to talk about any of the other books that you've authored?
Well, I think that they all fit together in a weird kind of way, even though they were written over a span of 4 years. So I think we'll touch on some of them. Brave New Brain, which is the one that appealed to you, Jesse, I think is interesting because it kind of sums up what is happening today in neuro research. You can't pick up a newspaper or look at TV without seeing something almost every day. Of course, the latest is President Obama's $100 million initiative to map the brain. And frankly, that's a drop in a bucket because the NIH has been spending well over $5 billion a year on research that's related to the brain or the mind.
It's funny, 100 million sounds like a large number until you realize there's 100 billion neurons in the average human brain, so it's actually only devoting like 0.1 cents per neuron.
So true, so true. But what's spurring all of this fascinating research on the brain is a perfect storm of events that have come together. And one is that the boomers, like myself, who make up the largest demographic group in the U.S., and even with the recession, the best off financially, are not going gently into that good night. We're kicking and screaming, and we're pushing for more research to keep our brains healthy as we age. Of course, the Alzheimer's epidemic that's coming up is another impetus for us to learn something about the brain so we can forestall not just this mental condition, this deterioration, but the enormous economic, social, and psychological costs that are associated with it. Around this time, what also has happened, of course, is that technology has advanced enormously. We now have miniaturization, which enables us to go where no human hand has gone before. We now send little molecules in there instead. And of course, the power supplies are miniaturized also. And we'll talk about that a little bit with the Bionic Brain. And business has recognized that the brain is big business. So all of these things have contributed to an enormous spurt in brain research that, in fact, is encouraging cooperation among the various branches of science that never cooperated before. And even, engineers are working with neuroscientists who are working with biologists. But, we've learned more about the brain in the past 50 years than we have in the preceding 50,000. And I'd say maybe even in the past 2 decades. But we still know so little about the brain and how it really functions.
I think there definitely is a giant consumer market for stuff like this if we can prove things actually work and are even relatively safe.
I worship at the altar of chemistry. I really do. And obviously, most of us wouldn't be alive today if it weren't for the enormous advances in biochemistry and medicine. So taking a pill to help you function better cognitively could be a really good idea if we know they're safe and if we really know what the effects will be. So that's the caveat I have about that. And also, these smart pills don't really make you smarter. They make you able to focus better.
Yeah, I think a lot of what people are, considering, smart drugs like the study drugs like Adderall and modafinil, it's more focus enhancing or wakefulness enhancing than intelligence enhancing. Although there are some of these other ones like that you're not necessarily going to feel the effects of, like, paracetam, I guess, would be an example.
Well, I think this is a very, very fruitful and interesting field, and I think there's a lot to be learned about it. And I'm concerned that what is the estimate now, Jesse? Is it 25, 30% of college students are routinely taking ADHD and other type drugs off label?
Yeah, that's a little higher than the numbers I've heard, but on the other hand, I wouldn't be at all surprised, and it's probably the kind of thing that's more underreported than overreported. And
I think there could be more research done in this, but I don't think there's going to be too much research done yet on brain enhancement because most of it is aimed towards brain repair. One thing that works enormously that is free, readily available to anyone, and has very few, if any, side effects and will absolutely enhance your mental performance is...
It's going to be sleep.
No, exercise.
Oh, exercise. Okay, well, exercise also, sure. Sleep is one of these things that gets brought up by almost every single guest I have on this podcast is like just one of the easy wins that we could all get more of and that almost nobody takes advantage of.
Well, I think sleep is greatly overrated. Well, solid, straight 8 hours of sleep is overrated. And in fact, it's artificial. There was some interesting research I found when I was doing my day in the life of your brain. And I wanted to know how we fell asleep and how we woke up. And I found this great research from an historian and some neuroscientists at the same time. And what they postulate, based on historic research, is that the 8-hour sleep cycle we have is completely artificial, and it came about with industrialization. Before the industrialization, we went to sleep with the sun, and we woke up with the sun. And that can be 12 hours. In the winter, it can be 14, 15 hours. And so
Sure.
People typically, according to what the historian found, would sleep for 4 hours and then wake up in the middle of the night and play a musical instrument, have sex, write down their dreams, chat with their friends, have sex, and then go back to sleep again for another 3 or 4 hours. So the thing that so many people worry about when I speak, sleep is always brought up, about insomnia. And I said, well, if you're waking up at 3 or 4 a.m., maybe it's not insomnia. Maybe you're just waking up and you need to do something for a couple of hours and go back to sleep for a couple of hours. So while sleep is important, it doesn't have to be in that 8-hour cycle. And I am a great believer in napping.
I always love kind of hearing people talk about alternate approaches to sleep because, yeah, it does seem like one of these, things that we do find ourselves sort of trapped in habituated ways of doing it, but there's probably a better way.
Well, I think people get upset about it. They get very, very deeply concerned that they can't fall asleep and they can't fall asleep. Or more commonly I hear, because I'm talking to an older group, is I wake up at 3 or 4 and I can't get back to sleep, and and they worry about it. But to come back to what's good for your brain about exercise does many of the things that that many smart drugs, so-called, would do. Of course, one of the things that they do is boost the level of blood, pulsing through your brain, because blood carries oxygen and glucose, which energizes your brain. Exercise does that for sure. Those of us who run or who work on a stationary bike or who bike know that about 5 or 10 minutes into that exercise, it's like mental clarity hits you right there in that sense. That's the blood. The other thing, of course, is that it stimulates the production or the uptake of a number of neurotransmitters. Dopamine, norepinephrine, serotonin, and of course, it releases endorphins, which make us feel good. And the other great thing for your brain is that research is now finding the risk of dementia is associated with stress, anxiety, and depression. That those conditions can increase your risk of developing dementia as you age. And while our listeners may not be in the group where they think they're not worried about keeping their brain sharp as they age, everybody's aging all the time.
Yeah. And I think people that are listening to this podcast have been, hearing that point hit repeatedly, that, really things you do in your youth, it's all having, continued effects. And even if you're not feeling it yet, it's like the ceiling of your cognition can be slowly lowering and you won't be aware of it until it hits you in the forehead in your 60s.
Right. And you can't count on genetics, good or bad, alone, because genetics are so much affected by everything. You know about epigenetics, correct?
Yeah.
And that's the sort of chemical overlay on our genome, the epigenome, which affects which genes are expressed or activated and how much. You can actually, you're born with your blueprint that's not going to change, but not all of those genes are equally active, nor will we want them to be. And so what you do and think and feel and the environment that you're in absolutely changes the way your genes are expressed. And that, I think, you can affect for a long time, probably well into your later years.
I think the epigenetics are something that really changes almost on a hour by hour, minute by minute, meal by meal sort of basis. I mean, really, we're constantly sort of changing what genes get expressed throughout the day, as I understand it. It's just a really quick feedback cycle.
It is. And in fact, as you know, your brain is changing every second. As you and I are talking, our brains are changing. As we're creating new networks among neurons, which is where the information is held too. And a lot of that is due to something called myelin, which is produced by the glial cells, the white matter in the brain. And one of the things that happens as we age is that this myelin, which is a super insulation, begins to degrade. And that super insulation lets messages zap among our neurons very, very, very quickly. And as we age and it begins to degrade, the messages still get through, but a lot more slowly. I like to say that when you're 20s, your brain is a Maserati. And by the time you reach 60 or 70, it's more like a Ford Taurus. So slower, but it will still get you there. But that lets us jump to another subject you were interested in, which is the bionic brain.
Yes, please.
Yes.
More.
Well, I was just thinking the other day, one of the things that's postulated by the scientists I interviewed is that within the next, they say decade, but I think it might be longer, we will have a chip like the ones we have perhaps in our computers or iPhones that will either rest on the skull or inside under the skin. And we will be able to access information on that as we do with the iPhone now. So it can be a little memory bank to increase our memory. And think about it now, when you're having a conversation and you can't remember who starred in the $6 Million Man, or even what that was, a TV show from the 60s.
Yeah.
You can look it up on your iPhone. You don't have to remember it. And that's going to be a great boost for people, especially who are having memory problems as they age, and for young people to be a great enhancer.
Well, I mean, for that matter, it's like if you have that chip in your brain is connected to the equivalent of a Wi-Fi network or WiMAX or whatever the standard is, then it's essentially you've got Google in your brain, which is the strangest concept ever, but it's not far off.
There's so much to be done. When I started writing The Brave New Brain, the idea I had for it that's repeated throughout the book is that science fiction, yesterday's science fiction, which I'm a great fan of, is becoming today's science fact. One of the things that I cited in there was a movie called The Terminal Man from the 1970s. It was written by Michael Crichton, who actually got his MD at Harvard but never really practiced, and is best known for Jurassic Park. And he wrote a book that became a film about a man who wanted to control his epileptic seizures and devised a deep brain implant with like a pacemaker to turn it off. And the movie goes on to other kinds of devious things he does with his brain implant. But that was science fiction in the 1970s. Today, there are 100,000 people walking around with deep brain implants and pacemakers for the brain that are implanted in specific parts of the brain. You can go into Brodmann area 25 and control depression. You can, with a flick of the switch, stop your tremors from either Parkinson's or epilepsy or something called essential tremor. And they're now researching using these for chronic pain. And in fact, just recently, they did some deep brain stimulation implants in a pair of women with early stage Alzheimer's. And they're hoping this will stimulate those parts of the brain that are affected by early stage Alzheimer's to become more active. It's amazing technology. And then the other thing, though, is that they are now a couple of areas of stimulating the brain that do not involve surgery.
Now, is this the transcranial magnetic stimulation that you wrote about?
It is, and that's been around for a while. That's using magnets focusing on certain parts of the brain to stimulate activity in those parts. And these have been used for depression for quite a while. In fact, McLean Hospital at Harvard has a whole website about how they use this for depression now, in place of electroshock therapy. And there's a whole other area that they're working on with this, and that is ultrasound stimulation of the brain, which is the same thing. You don't have to do any surgery. You just place these instruments, the ultrasound or the magnet, on the scalp in certain areas and stimulate those areas. And they're working on this for chronic pain, for OCD, and even for obesity.
I was just going to say, it's really interesting to me that something which seems like it would be like a very generalized sort of stimulation to the brain would have those sorts of effects. I mean, it seems like that would be like a massage for the brain, for lack of a better term, just something like a generalized, magnetic stimulation to a certain area. Because I mean, it's not like you're affecting individual neurons; you're affecting swaths of 10 billion neurons at a time when you do that.
That's true. And while they talk about, aiming for certain parts of the brain, you're absolutely right. And this is one of the problems that we have. One of the researchers working even on deep brain stimulation, the tiny little wires they put in the brain, he's working with people with locked-in syndrome who cannot move, speak, or do anything else, but still can think very clearly. And by inserting these very fine little wires in the right place, the people can communicate through a computer, or in some cases by thinking of moving the vocal cords that no longer work and transmitting that through the electronic thing to a computer that speaks for them.
It does work to the extent where we have things like, monkeys that are able to control robotic arms with their thoughts, and, people that are able to move, mouse cursors on computer screens with their thoughts. So it's like, in fits and starts, we are making some amazing progress.
Right. And a lot of the progress on the brain is coming out of our more recent wars. As you probably know, World War II gave us a huge number of new surgical techniques. And then with the war in Vietnam, we were finally able to lift people off the battlefield and have them in surgery within a matter of hours. And so there were big advancements in surgery going on there. And the big advances coming out of the wars in the Middle East are those on the brain, because closed head brain injuries are among the most devastating things that happen. So there are a lot of brain damage. Our wonderful warriors have brain damage from that. And of course, the other group are those missing limbs. All these are from incendiary devices, from bombs mostly. And so they're working very much on finding ways to help with the closed brain injury, with the damaged brain. But the robotic arm, the people now are able to move a prosthesis by thought alone. There's research, but now they're actually issuing them to some vets, that if you have enough nerve endings left in, let's say, your shoulder, the device can pick up the transmission. You think about moving your arm, those nerves are sparked and they connect with the prosthesis, and the arm moves as though it were your own.
Which gives you full-on like Darth Vader potential.
And the other thing they're working on now, of course, is stem cells. They have been implanting embryonic stem cells into mice. I assume they're mice embryos. And that research has led them to improve memory and function. So who knows what stem cell research will bring? It's had a gene replacement therapy and stem cell research have had kind of a checkered past, and they've had enormous promise for decades. But we may actually be gaining on that with the stem cell research now. But I'll tell you how fast it's moving. When I was writing Brave New Brain, I had actually sent it off, and it had gone through copy edit. And I had a section talking about the artificial retina and how it had been under research for the past 20 or 30 years. And the months before it was absolutely due to go to the printer, they perfected that. They implanted an artificial retina. Well, it's a big technological thing with cameras and things. They had people using an artificial retina who had been blind, who were able to actually see well enough to function. But that happened while I was writing the book. And then I see in here, when I look at the bionic brain, and I have a thing here, could implants help Alzheimer's patients? Then it says, from the research that I did, that's not an easy surgery, and who knows if we'll hit the right part, and it doesn't seem likely to happen. And I pick up the paper, and here it is from the New York Times. This is the Associated Press. In January 2013, which is where I found out and then looked up that they've been putting deep brain stimulation in people in Canada. Now they're doing it in the U.S. So this is how fast stuff happens.
Yeah, they use a couple Canadians as test subjects, and before you know it, it's safe for Americans. Sorry, I shouldn't have said that.
So I guess you've talked before about all the myths about the brain, right? The idea, too, that our brains are hardwired. It drives me crazy when someone says, I'm just wired that way, because our brains are not hardwired, except for a few really basic things.
I remember when I was a kid, we were taught in science class that like pretty much all your brain cells were there by the time you're like 12 years old, and all you do is just a slow winnowing off of brains dying over the rest of your life. And now we know that's entirely untrue, that not only are new connections constantly being formed, but there actually are new brain cells being made throughout your life.
They arise in certain parts of the brain, and one of them, fortunately, is the hippocampus.
Which is where we lay down memories.
Exactly.
Yeah.
And one of the interesting things about the rodent research on that is that they took two groups of rodents and they gave them a dye so that they could see under, whatever, microscopy, or if they sacrificed them, which is the wonderful euphemism they use, they could see later which brain cells are retained, because they know that not all of these new baby neurons survive. So they took half the rats and they sent them to Rat U. And they studied mazes, and they rode on those little wheels, and they exercised, and they ate well, and they were challenged mentally all the time. And the other rats went to the rodent frat house, where they basically lolled around, doing the equivalent of drinking beer and sleeping and watching TV. And when they sacrificed these rodents later and compared them with the new cells that had been marked with this dye, they discovered that the active rats had retained the neurons, the new neurons, and the rats that didn't exercise physically or mentally did not.
Wow, so now we've slandered both Canadians and frat houses in this episode.
And rats, yes. And we're back to exercise and the benefits of exercise, aren't we? And you mentioned something interesting. We were told that we would keep laying down new brain cells. Actually, the opposite happens. By the time you're born, you will have lost half of the neurons that were engendered in your embryonic fetal state.
Wow, that's amazing.
Continue to lose neurons all your life. And one of the theories, one of many theories, about a possible contributor to autism is that certain children don't go through that, what do you call it, winnowing process?
Yeah, like sort of weeding out the ones that aren't getting used?
Yes, that they have too many brain cells, that they actually, rather than a lack, they have an overabundance of them. Because your brain, your whole body is just this lean, functioning machine. And it gets rid of the things it doesn't need. Nature is marvelous that way and ruthless. So what you're doing from birth on is you're laying down the myelin, the insulation among, on the axons among the neurons. And you will continue to do that until you're in your 20s or so. And then you'll stabilize. And then in your 40s or 50s, it will start to as I said, degrade, which is why you can't throw a fastball as fast at 50, because nerves carry those impulses to the arm, among other things. And the neurogenesis will continue up until death. They have had terminal cancer patients who donated their brains for research and who were injected with this dye. And they found when they autopsied the brains after death that they continued to make new brain cells up until the time of death.
Wow.
So that goes on, which is amazing. And the neuroplasticity, we have examples everywhere of people with horrific brain injuries where a part of the brain is taken over for the part that's missing or damaged. And in some children that have very, very severe epilepsy, where the seizures cannot be controlled, they actually remove a whole hemisphere of the brain, half the brain. And if that's done young enough, the child functions perfectly normally.
So that they actually take out half the brain rather than just severing the corpus callosum?
I've always assumed they removed it. And you know something, Jesse, I don't always remember what I wrote.
I just wonder, like, if you had an empty half a brain, like, I mean, do you put like gelatin in there to keep it full? Or you off balance your whole life? I mean, that just seems like a waste of space.
Or something like a breast implant, just sort of filled with a little jelly.
Fun at parties. Well, anyway. But as a journalist, you're researching the research of others and deciding what is most apropos to your broader topics.
Yeah, and trying to put it into language that we can understand.
That's actually one of the things I definitely should point out. Like, it was an intensely readable book in a good way. It's like you were making some very complex ideas very accessible.
Thank you so much. I'd love to hear that. I would say that I write so my 12-year-old grandson can understand it, and so that a neuroscientist will enjoy reading it.
That's a heck of a straddle, but no, I think you really hit that, and I would enthusiastically encourage people who are looking for that sort of broad scope material to check out your books.
Thanks so much. And my website, of course, which is my name, www.judithhorstman.com.
Yeah, we'll put a link on the website also. Thank you very, very much. It's been really good talking, and we'll definitely talk again if that's all right with you.
Oh, that'd be great. Just give me some time. That'd be fine.
So thank you very, very much to Judith Horstman for all the information that she shared with us right there. There was a ton of great stuff, really interesting conversation that I enjoyed immensely. I'm not sure if this is going to make it into the episode or not, or wind up on the cutting room floor, but Judith is 73 years old, so she's no spring chicken, but boy, is she a sharp woman. So anyway, just further evidence that if you take care of your brain right, you're going to get a lot of use out of it in the future. And I know that Judith still has decades of plans for use of her own brain, and hopefully we'll get to spend a little bit of our time picking that brain as time goes on and in future episodes. Anyway, moving right along.
Smart Drug Smarts. Ruthless listener retention gimmick.
As promised, a little piece of strangely uncharacteristic responsibility from your host, Jesse Lawler. Somebody mentioned to me recently that, hey, Jesse, if you're going to be talking with people about all these pharmaceuticals that they can and maybe will be taking partially as a result of your sounding enthusiastic when you talk about things, you might want to kind of put some kind of little legal disclaimer in there so people don't do stupid stuff and then sue you. And the more I thought about it, the more I thought, yeah, that's a pretty smart idea. So with no further ado, it's my pleasure to announce our pithy little legal disclaimer, which will be probably at the back of all future episodes, but we'll play it now just so you can hear it.
Smart Drug Smarts should be listened to for entertainment purposes only, although some guests on the show are medical doctors, most are not, and the host is just some random guy. Nothing you hear on this podcast or read at smartdrugsmarts.com should be considered medical advice. Consult your doctor and use some damn common sense before doing anything you think might have a lasting impact on your brain.
And speaking of legal, that is not all. Episode 16, coming at you in a couple of weeks, is going to be with a real-life attorney. Yes, not a scientist, not a researcher, not somebody that does a whole lot of smart drugs and wants to be a human guinea pig, but a U.S. attorney who's going to tell us a lot of stuff about the legalistics of buying and selling pharmaceuticals that you might not actually have a prescription for, and what that means both from your perspective as a buyer and the seller's perspective as a seller. And even the postal worker's perspective as a postal worker. So, yeah, lots of interesting things to talk about there, but that'll be in a couple weeks from now, so stay tuned.
Smart Drug Smarts, the podcast so smart, we have smart in our title, twice.
And now that is the entire episode. Episode 14 in the history books. If you liked what you heard, please recommend this podcast to your friends or passenger pigeons that are going to be dive bombing people or anything like that. Just, spread the word, write it on a brick, throw it through somebody's window. The show notes for this episode will be online at www.smartdrugsmarts.com, including the links to anything that we talked about here. I'm going to be back at you next week. Same time, same podcast, same iTunes page, and the same unflagging commitment to helping you fine-tune the performance of your own brain. Have a great week and talk to you soon.
You've been listening to the Smart Drug Smarts podcast. Visit us online at www.smartdrugsmarts.com and subscribe to our mailing list to keep your neurons buzzing with the latest in brain optimization.